Hello, I'm Thomas Nyman, the MajorTim.space 2023 to 2024 Achievement Young Ambassador, and today I will be interviewing Mike Scott. Mike, could you introduce yourself?
Hi there. Yeah, Mike Scott here. Well, I guess you know about my background. I worked with the shuttle program for 11 years, and I've been with the space station program for a little bit over that. I do electrical power planning for the space station. And I'm from Texas. I grew up in Texas, went to school in Texas, and that's pretty much me in a nutshell.
Okay, so let's start off with who or what inspired you to start your career as a power resource officer in the ISS Systems Division?
Well, it started really when I was in like 6th or 7th grade, and it was I wanted to work in the space program. I didn't know exactly what I wanted to do, but um,
Yeah,
so I went to Kennedy Space Center, and that is a wonderful place. It's a huge wildlife preserve, but they launch rockets from there too. All the human missions to space have launched from there. So, so that's, I thought I wanted to work there when I was growing up, and then I realized that
yeah.
there are other space centers around to work at. So
Mhm.
that's where I got my, that's what turned on the thing in my brain that said I want to
Yeah.
work in the space program.
So have you always been interested in space, or?
Not before 7th or 8th grade, but after then, definitely. Mostly interested in human space flight, not terribly interested in the probes that we send out
Yeah,
to different planets, but mostly human space flight. Yes.
yeah. So what do you enjoy most about your job?
Having my hands directly on the vehicle,
Yeah,
being able to directly impact what happens on the space station, um, and working in mission control. That's where all the action is in the control center. So that's my
yeah,
favorite thing, to sit up there.
yeah. What's the most interesting thing that you've ever had to do in relation to your job?
Well, sometimes the things on the space station, the hardware fails occasionally, and
Yeah,
you have to come up with a solution pretty rapidly within a few hours to keep the power systems in balance. So
yeah,
we had a particular failure several years ago that required me to do that, and so that's it's very challenging, and it's a little bit scary, but
yeah.
that's that's what I would say is when things fail on the station and you have to come up with a solution.
So do you find your job difficult in that regard?
It's difficult when things fail and you have to come up with an answer for how to reconfigure things on short
Yeah,
notice. But day to day operating the station, it's not terribly difficult once you
yeah.
know what you're doing.
So when the power supply is cut by shadows, how do you manage?
Well, we have batteries, of course. We go into
Mhm.
the shadow of the Earth, 15 or 16 times every day. So we have nighttime about in a 24-hour period. We have like 15 or 16 times where at night. So we have batteries. So when you have shadowing, you not every array is shadowed, not every part of the arrays. So you have reduced power. You still have some power available, but
Mhm.
mainly what we have to do is turn off some things. So
Yeah,
we figure out ahead of time how much shadowing is going to be on the solar arrays, depending on there are several things that could shadow the arrays. But once we compute how much shadowing there is on the arrays, then we actually make a list of things that need to be powered down, and then we go to the different groups and get them
yeah,
to sign off on powering things down. And then when the time comes and the shadows appear, or we've got the arrays feathered where they're not generating so much power, then those groups will have agreed already to turn off their equipment, and so they start turning that stuff off, and we start watching
yeah.
for it in the telemetry.
Hmm. So 2 or 3 days ago, I read an article that NASA lost contact with the ISS following a power outage. What exactly happened, and how was the issue rectified?
It could have been. I don't recall specifically what that was.
Yeah.
It may have been something on the ground. We had a problem with power in the control center, so that's
Hmm.
probably what you were reading.
Yeah.
So that was a temporary thing. They have, if they lose power to their computers in the control center, they have these laptops that they can use. They can even go to a different building and use them if they need to,
Yeah.
to talk to the station and to see the telemetry and send commanding up to the station. So I remember they broke out the laptops a couple of days ago. So that's probably the incident you're referring to.
Yeah.
And then something, the root cause was worked on and fixed in the building
Hmm.
to re-provide power to the computers in the control room that you see on TV.
Hmm. So has one of the solar panels ever broken off?
No, they haven't broken off, but there is a chance to damage the solar arrays. There's a group that analyzes everything that happens with, like, when you have a resupply spacecraft coming up, because the little rocket plumes from the control systems on those resupply craft, and also from human spacecraft coming up to the station, they control their attitude and their motion by using little rocket thrusters, and the thrust from those rocket thrusters continues off. It's not like in the atmosphere where it slows down once a rocket engine is fired. In our atmosphere, the plume from that will slow down, but in space it keeps going, so it might impinge or impact on the solar arrays and degrade them. So we have a group that studies those and analyzes them with computer programs to figure out, okay, we've got this array at this angle. What is the rocket plume impingement on that? And we have it at this angle. What's the impingement? This angle, what's the impingement? And they have
Yeah.
certain criteria that are acceptable for rocket plume impingement.
Yeah.
So you can break a solar array if you have it in the wrong place and um, the wrong rocket plume hits it. You could snap one of them. That's actually a concern. There's also Longitudinal shadowing. I'll leave you to look that up on the internet. But basically, if you there are these four rods that go up in the middle of all the arrays. You can see them if you look at close-up pictures. And if one of those rods is shadowed by another rod or by something else, it can contract, and the other rods will expand. So you could have something snap because of the thermal effects of that also. So that's Longitudinal shadowing is what they call that. And then the group I mentioned studies all that as well.
So why do you not have more? Why don't you attach more solar panels to generate more power? Why do you only have 16? Because I'm just thinking, if you added, let's just say, 4 more, then you'll have more power.
Well, they are adding some on top of, kind of on top of the old ones. If you look up ROSA, roll out solar array, they're adding more. Uh, so we have, out of our 8 power channels, we've added 6. So we've got 6 of 8 power channels with the ROSA arrays, and they're kind of blue in color. If you look up pictures of them, they're shorter than the old arrays, and they're in the middle, kind of between them. I can't really share pictures during our interview on the computer here, but if you just look up iROSA or ROSA, or you just look up pictures of recent photos of the station, you'll see those new arrays going on there.
Yeah.
And that's
So.
because the old arrays have degraded over time from micrometeorites and orbital
Yeah.
debris impacts and
Mhm.
erosion and contamination. Layers of junk getting deposited on them from rocket plumes, like we were talking about earlier.
Mhm. Yeah. So does the ISS need fuel to stay in orbit, or does it just float?
Well, it does, because we have to reboost the altitude occasionally. It doesn't just there's a tiny bit of drag. So normally it just keeps going around by itself, but there's a little bit of drag, so it lowers the altitude over time. So to boost the altitude back up, they need to fire a rocket motor for several minutes, and then that boosts our altitude up by several miles. Um, so in that sense, yes, it needs fuel, but not a lot.
Yeah. So did you ever have any desire to become an astronaut?
No, I never did. Some of the people I work with do, and in fact, a couple of astronauts have come from the groups I've worked in. Clay Anderson is one of them. I used to work in flight design and shuttle, and Clay Anderson worked in the
Yeah.
shuttle flight design group before I was there. So I never really had a desire to do it. I just like being on the ground.
Yeah.
using my brain to do the job, but still be involved.
Yeah. Do you envisage that an issue could arise with the ISS power systems, which would result in evacuation of the onboard astronauts?
Well, there are scenarios that could do that. Yes, one of them is called cascading failure, where you have a sudden failure of a component and it forces power to shift over to another channel, and then that other channel gets overloaded, and suddenly it switches power to another channel, and it just cascades down until you're left with hardly anything working. So
Yeah.
so that's one scenario that could lead to that. There are other ones, but that's the main one we're concerned with from a power standpoint. There are other things that could lead to having to evacuate the station. Toxic atmosphere, like if ammonia leaks into the cabin, or if they have a rapid depressurization, depending on which part of the station. Depending on which part of the station has the depressurization, they might have to leave because it could be in a module that's between where they are and their escape spacecraft.
Yeah. So, what areas of Earth does the International Space Station fly over?
Well, it has an orbital inclination is 51.6 degrees, so it flies directly over everything between north 51.6 degree latitude and south 51.6 latitude. It covers every square foot of land in that band, but it can also see north of 51.6, line of sight, because they're 250 miles up. It can see a line of sight past the 51.6 mark and south past the 51.6 mark to the south. So doesn't go over the poles. It just wasn't designed that way for a number of reasons, but it covers a vast majority of the Earth's population. You can see it going over.
How long is the ISS lifespan, like, before it breaks down?
Well, it's been extended a couple of times over the years. Right now, I think the ending life is expected 2030 or 2031. I can't remember which one. So here in about 7 years, is when we expect to have to deorbit it, and there's no way to save it. You can't send it out to an orbit that's way high up or out to the moon or anything. It's not designed for that type of orbit. The thermal stresses on it would break it up. So it's going to be deorbited all in one piece.
Yeah. So, what happens if there is a fire on the ISS?
Well, the crew is trained to go through a response to that on their own, without the ground being involved, and also the computers on board will reconfigure the station. They'll shut down ventilation fans and things like that to keep smoke from being distributed through the station. But the crew has equipment on board to fight the fire. They have something they can put over their face where they can still breathe. They've got equipment to take readings to make sure that they've got the fire out, because the fire is probably going to be behind where they can access. It's going to be behind a panel. So they've got these fire ports where they can check to see if the fire is still going, see if there's smoke behind a panel. So if the fire is bad enough and they can't control it, then they'd probably evacuate, get in their spacecraft that they came up on, and then depart. But the crew can put out fires that come up with equipment. Routinely they train on that kind of thing.
How many countries partnered to build the ISS, and do all these countries still contribute?
I believe all the countries still contribute. I don't remember the number. I think it's like 15 or 16. It's a large number, although you have to kind of read about details about what each one did if it's not obvious. I mean, the United States, it's obvious there are certain modules that are ours. The Russians have their own modules. Europeans have a module. The Japanese have a module. The Canadians have the robotic arm that they developed the arm technology for space shuttle, and then they did the space station afterwards. But a lot of other countries contribute. A lot of other countries have science that's going on board the station. So it's all part of the package.
So, which country built the first ISS component?
That's a good question. I'm not really sure I know the answer to that. Um, I think the U.S. and the Russians built the first two, and they joined in orbit to start the assembly. Um, so I think probably Russia built the very first module, but that's a good question. I don't know exactly. I was not involved in the space station program back then.
So, how does the ISS maintain power? Is it the solar panels entirely?
Yes, strictly
Yeah.
solar for generating power. It
Hmm.
would be nice if we had something else like an RTG where you could generate power no matter
Yeah.
what the sun was doing.
Yeah.
But there are hazards associated with that for the crew. So
How much power can the
solar
ISS
power is what
generate?
we have.
Yeah. How much power can the ISS generate?
I'm sorry.
How much power can the ISS generate?
How can
How much
how much
power can
power
it?
can it
Yeah.
generate? I think it's around 100 kilowatts. No, it
Wow.
can generate more than that, but I think we use around 100 kilowatts. So
Yeah.
probably 130, 140 kilowatts of power we could generate
Yeah.
with our existing arrays.
Hmm.
I mean, with the new arrays plus the old arrays.
Yeah. Does the ISS need heating?
Um, that's really not my area. I'm not sure. I don't think it does because,
Yeah.
well, it's in sunlight most of the time. It's in shadow for a part of the time, but
Yeah.
mostly it's in sunlight, and so that uh, overall doesn't need heating. We have a problem with heating there, but the the uh, the pressurized modules they have these things called shell heaters,
Yeah.
and to keep condensation from forming on the inside walls of the pressurized modules, they use these shell heaters to keep the temperature of the actual um, the shell of the module. They keep it up above a certain temperature so you don't form dew,
Yeah.
you don't form water droplets on the inside of the shell, which could cause corrosion. So in that
Yeah.
sense, they need heating. But inside, I think there's plenty of equipment to generate heat that the crew is comfortable. I don't think there's heat added to the environment inside the station. I think there's plenty of electronics giving off heat, and we're trying to get rid of that heat through the cooling systems. So, in that
Yeah.
sense, no, you don't need to heat the inside of the station. So there's different ways to answer depending on specifically what you mean by heating.
Yeah. Could you boil water on the ISS? Like, is it possible?
Sure. Yeah, it's the same environment that you're in that you and I are in right now. It's 14.7 psi atmosphere. I don't know what that equates to in bars, but it's a standard atmospheric pressure, pretty much a standard atmospheric mixture of gases. So if you were to heat water to boiling point, yeah, it would boil. But the trick would be keeping it in a container.
Yeah. What happens when the ISS is hit by debris?
Well, it's hit by debris pretty frequently. Most of it is real tiny because we can track the larger pieces from the ground and avoid them by firing a rocket motor ahead of time. But when the little pieces hit, they cause damage, and you can see pictures of that on the internet if you go out and look. There's a big part of the radiator panel that's been hit and folded back by a piece of debris. Occasionally, it's pretty rare, but the astronauts can hear debris hitting when it hits like the metal frame of the pressurized modules that they're in. If it hits way out on the end of the truss, they're not going to hear that. But if it hits one of their modules um, on some metal, on part of the metal framing, they can hear that. Um, there's also the white material that's around the modules for insulation purposes. It also acts as a projectile barrier. So like a bulletproof vest that a police officer would wear, it'll stop a lot of the small pieces, and I don't think they hear it when those hit. Um, but they've reported a loud clanging noise before, and that was orbital debris hitting them. Um, Now, if the orbital debris hits a key piece of the station, like an electronics box, then it'll cause a failure of something. Um, we've had debris hit the radiators that get rid of our heat and go right between the cooling loops. So it didn't impact our functionality, but it's like a bullet going between two little pipes. It went right between them and didn't hit either one of the pipes. That kind of thing happens. So,
has there ever been a major issue caused by the debris?
there has not been a major issue caused by orbital debris that I'm aware of. There may have been something bigger before my time there, but I'm not aware of anything that actually caused. Actually, I do remember something caused a failure on part of the arm 2 or 3 years ago. They took a debris hit, but so that could be considered a major impact because they use the arm for all kinds of things. But
Yeah.
nothing that has caused a depressurization of the crew modules or anything like that. No.
So there's not been anything substantial.
Right.
Yeah. So, what advice would you give to anyone interested in pursuing a similar career?
Well, first off, don't skip school and study and learn something technical. Learn about math and science, technology, engineering. Those are the routes that'll lead you to the kind of job that I have. There are other jobs at NASA, of course, other than technical jobs. But if you want to do engineering, if you want to do flight control, if you want to design things, that's going to be engineering uh, and math, but mostly engineering. Take engineering courses and just do as well as you can. You don't have to be a straight A student, but you have to work hard and get your grades and um, try to have. If you can't go straight into NASA type work, then get other jobs first and show that you're willing to work hard and get your resume built up and then work for NASA. But there are plenty of jobs to do other than technical work.
Yeah. Yeah, well, it's been great speaking with you. Thank you for giving your time to do this.
Yeah, Thomas, thank you for the questions. I appreciate it. Good luck to you guys over there.
Thank you. Bye.
Bye.